Alright, so this video we're going to look at the derivative as a function. We're going to find the derivative using the definition. Alright, so if we have a function f of x and we want to find the derivative of that function, we can find it by the limit as h goes to 0 of f of x plus h minus f of x divided by h. Alright, so this video, all the derivatives that we take, we're going to be using the limit here. Now, as you go forward in your calculus class, you're not going to take derivatives like this, okay? The sections that come after this in the calculus book, you're going to learn some rules to find derivatives and all that good stuff. All right, so first let's look at a graph here. It says the graph of a function f is given below. So this graph here, this is the graph of our function f. And they want us to use it to sketch the graph of the derivative. All right, so you may run across some problems like this. So to graph the derivative, let's just draw that. Now there's some key points here to graph this thing. Notice here at this minimum value, this maximum value, and then we've got this minimum value here. All right, so these white lines that I've drawn, those are tangent lines. Okay, tangent lines. And you notice that the tangent lines, they're horizontal, so that means their slope is 0. Okay, so where that's 0, the derivative is 0. Okay, the slope of the tangent line is 0. F prime would be 0 at that x value. And then same thing here. This point would be, for the derivative, would be 0. And this would be 0 also. All right, so now what we've got to do is we've got to kind of sketch in this graph. All right, so you can look at this as this graph here is decreasing. Okay, it's decreasing. Or also you could look at anywhere on this graph. I draw the tangent line, okay, and I can draw a bunch of tangent lines like this all the way to this point right here. But as I'm drawing these tangent lines, notice the slope of the tangent lines. These tangent lines here, those slopes would be negative. So the derivative would need to be negative. F prime would be negative for all the x values that are less than this one. Okay, whatever number this is. Okay, it's just some number. We'll call it maybe a. So all the values less than a would be negative for the first derivative, because all these tangent lines have a negative slope. And so we know that the graph would kind of come in here like this. They would all be negative values. And then here where the tangent line is horizontal, that's the derivative of the value of the derivative would be 0. And then as we get past this value, this point A, or x equal a, notice these tangent lines here, they have a positive slope. So that means the first derivative would be positive. So what it would do is it would come up, and then, well, it would come back down because we have another horizontal tangent line. So it's 0 here, so it's going to come down and go through here. All right, see the slopes of the tangent line are positive, and see all these values between a, and let's just call this b, and let's call this c right here, where we have our horizontal tangent lines. Let's just call it a, b, and c. So notice here at B, and we call that C. Or that this would be A prime, B prime. We'll just differentiate them, okay, to let us know, this is the graph of the derivative. But notice all the values between this A prime and B prime, they're all positive. They're all above the x-axis because all the slopes of all these tangent lines from here to here, all of them would be positive. And then notice here, it had the tangent lines, the slope of the tangent lines would be negative here. So it's going to come back down. So it's going to come down here, and then it's going to come back up because it's going to have to go through here. See where this tangent line is horizontal, where it's 0. And then once we see all the tangent lines from here to here, the slopes of all those tangent lines are negative, so the derivative needs to be below this. All right, and then notice here, once we get past C here, all these tangent lines are positive, so we know it's gonna come back up like that. And so that's a rough sketch. Okay, it's a rough sketch of that graph, but that's the thought process. Okay, so wherever you have a horizontal tangent line for your function f, remember this is f and this is f prime. So for your function f, if you have a horizontal tangent line, that's where the derivative is 0. Okay, and then if you draw tangent lines on f, if the slope of those tangent lines are negative, well, the first derivative's negative. If the slope of the tangent lines are positive, then the first derivative is positive there. All right, so that's just kind of gives you an idea of, a picture of it, gives you a picture of it. All right, so let's look at some problems. They want us to find the derivative of f. All right, so to find the derivative, we're going to use f prime equals the limit as h goes to 0 of f of x plus h minus f of x, all that over h. That's this, what we had up here. Okay, that's this. I just wrote it down again so we could see it. All right, so let's find the derivative. All right, so the derivative, f prime of x, is equal to the limit as h goes to 0 of f of x plus h. Okay, so f of x plus h, so that means we're going to take the x plus h and we're going to plug it in for x here and here. So that's going to be x plus h cubed minus x plus h. So that's our f of x plus h minus f of x. Well, what's f of x? F of x is x cubed minus x. And then that's all over h. All right. So let me show you. This is f of x plus h, and this is f of x. All right, so that's what we have. So this right here, doing this f of x plus h, taking the x plus h and plugging it in for x, that goes back to what you learned in pre-calculus, college algebra, those classes. All right, this f of x plus h, it says replace all the x's with the x plus h. All right, so then we get f prime of x is equal to, now, what we're trying to do here is we've got to simplify this thing. We have got to cancel this h here out of the denominator. Okay, we want to get this h out of the denominator. All right, so let's multiply all this out, combine like terms. So let's look at the x plus h cubed. So what I'm going to do, I'm just going to come over here to the side and I'm going to multiply it out. All right, so that's x squared plus 2xh plus h squared times x plus h. So all I did is I multiplied the first two together and got this. Just FOIL it. Now I'm going to multiply this to this. So I'm going to multiply the x times each term and then the h times each term. And so that's going to be x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed. Starting to run out of room there. And that's going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. All right, so that's what just this first term is. All right, so that's going to be the limit as h goes to 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed. All right, so let me erase that now. All right, so that should be easy for you there. That's just algebra. All right, and then I'm gonna distribute the negative, so minus x minus h. Whoop. I messed that up, didn't I? That should be an x cubed there. No, I'm sorry, that was right. That was right. That was right. Never mind. Minus x minus h. Forget what I said. Yep. Minus x minus, yeah, because we're replacing this with x plus h. I don't know what I was thinking. I was looking at something else. Forgive me. Okay. All right, and then I'm going to distribute the negative here. So that's minus x cubed minus, plus x. And that's all over h. All right, so all I did, I cleared the parentheses. All right, so now let's combine like terms. So let's see. The x cubes cancel out. The x terms cancel out. And that's it. All right, so that's 3x squared h plus 3xh squared plus h cubed minus h, all that over h. All right. So notice here we can factor out an h. So let's do that. So that's the limit as h goes to 0 of h times 3x squared plus 3xh plus h squared minus 1, and all that over h. And you can see here how the h terms cancel. So I get f prime of x is equal to the limit as h goes to 0 of 3x squared plus 3xh plus h squared minus 1. And now we plug in 0 for h, so that's 3x squared plus 3x times 0 plus 0 squared minus 1, which is just 3x squared minus 1. And there's our answer. All right. Now, like I said, you're not going to take derivatives like this, but you got to learn this. You might have, your teachers will probably give you a problem on the test where you got to find the derivative using the definition. Okay, this problem actually you do it in one step. Okay, it's very easy to do, but that's the next section, the next video. All right. So now let's look at this one. So let's find the derivative. So f prime of x is equal to the limit as h goes to 0 of f of x plus h. So that's going to be the square root x plus h minus f of x, which is square root of x, all that over h. Once again, here is f of x plus h, and there's f of x. So for the remember, for the f of x plus h, we're just replacing x with x plus h. All right. So now, how in the world do we work this one? Because remember what I said, we got to get this h here out of the denominator. Okay, got to get that h out of the denominator. So if you remember when you took college algebra or pre-calculus, if you had something like this, and you had to rationalize a denominator, you would multiply numerator and denominator by 2 plus square root of 3. Well, in calculus, a lot of times we'll rationalize the numerator. So I'm going to multiply numerator and denominator by the conjugate of the numerator. All right. So this is going to give us the limit as h goes to 0. Now let's multiply this out. So that's going to be what? Square root x plus h squared minus square root of x squared over h times square root of x plus h plus square root of x. Okay. Remember, this is a minus b times a plus b, which is just a squared minus b squared. And so this is going to be the limit as h goes to 0 of x plus h minus x over h times the square root of x plus h plus the square root of x. All right, and then you can see here the x's cancel out. And so this is going to give us the limit as h goes to 0 of h over h times the square root of x plus h plus the square root of x. And you can see here the h's cancel, so that's the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. And now I can plug the 0 in for h, and so that's going to be 1 over the square root of x plus 0 plus the square root of x, which that is just 1 over 2 square root of x. And there's your derivative. All right. So just remember, everything we're trying to do, we just want to get this h out of the denominator. All right, let's look at the next one. All right, so we've got f prime of x is equal to the limit as h goes to 0. Now we've got what? The limit of f of x plus h. So what's f of x plus h? Well, that's 1 minus x plus h. Don't forget to put that x plus h in parentheses because it's minus the whole thing over 2 plus x plus h minus 1 minus x over 2 plus x, and then all that over h. All right, so before we start simplifying this, let's write one more step. Okay, one more step. And all I'm going to do in this step is I'm going to distribute that negative there, and that's it. All right, so that's going to give me 1 minus x minus h over 2 plus x plus h minus 1 minus x over 2 plus x, and then all that over h. All right, so that's all I did in that step. Now, how do we simplify this? You already know how to do it, or you should. All right. So to simplify this thing, simplifying complex fractions. Okay, you did that in algebra. We can look at this h as being over 1, and we're going to get a common denominator of this denominator, and the 1 here. Well, hopefully you can see that the common denominator is 2 plus x plus h times 2 plus, times 2 plus x. And I'm going to multiply that to each term. So all I did is I'm taking the common denominator, which is this, and I'm multiplying it to each term. And so what happens here is this and this cancel, this and this cancel. All right, so I'm going to get the limit as h goes to 0, and that's going to be 2 plus x times 1 minus x minus h minus, let's see, 1 minus x times 2 plus x plus h over h times 2 plus x times 2 plus x plus h. All right, so there we go. So that's multiplying each term by the common denominator. So what I've got to do now is I'm going to have to multiply all this out. So I'm going to multiply this first term times the whole thing, and the x times the whole thing, and then the same thing here. So this is equal to the limit as h goes to 0. So let's multiply through by the 2. So that's going to be 2 minus 2x minus 2h, then multiply by the x, so plus x minus x squared minus xh minus, and when you multiply this, that product that you get from multiplying this, make sure you put it in parentheses because it's minus the whole thing. Don't leave that parenthesis out. So let's multiply everything by 1. So that's 2 plus x plus h. And then multiply everything through by negative x, negative 2x minus x squared minus xh. And this is all over h times 2 plus x times 2 plus x plus h. All right. And so we get the limit as h goes to 0. All right, so all I'm going to do in this step, I'm going to distribute the minus sign, okay? I mean, you can do it in your head, but I'm going to go ahead and write it all out. So that's 2 minus 2x minus 2h plus x minus x squared minus xh minus 2 minus x minus h plus 2x plus x squared plus xh. And that's h times 2 plus x times 2 plus x plus h. And so that's the limit as h goes to 0. Now let's see what cancels. So we can see the 2's cancel out. The 2x cancels out. What else? The x here and this x cancel out. Yeah, I mean, if we wanted to, we could, you can come, well, I mean, we did that, but you can see if you add them all up, they'll cancel out. The x squareds cancel out. And so it looks like, well, let's see. The xh and the xh cancel out. And so it looks like we are left with negative 3h over h times 2 plus x times 2 plus x plus h. All right. And so now you can see the h's cancel, and that's the limit as h goes to 0, and that's going to be negative 3 over 2 plus x times 2 plus x plus h. All right, and so we're going to get, now we can plug the 0 in for h. I'm going to bring the negative out in front of the fraction bar. You can do that. So that's going to be 2 plus x times 2 plus x plus 0, which this is just 2 plus x, right? So that's going to be negative 3 over 2 plus x, and then 2 plus x times 2 plus x is 2 plus x squared. And there's your answer right there. All right, so that's taking derivatives using definition, doing the limit. Okay, it's not fun. It's a lot of work, and other than maybe the problem you might have to do on a test for this section, you probably won't ever do it again. Okay. All right. So we've got some other notations of the derivative. If you notice how I've been representing the derivative with this f prime, I had them all f of x equals, so I've had f prime of x. You could have y equals, that would be y prime, or you could write it dy dx, or df dx, or d, and then you could write the f of x dx, and then the notations you got here, d fx and d sub x fx. Those are just different notations for the derivative. So we got a definition that says a function f is differentiable at a if f prime of a exists. I think that should say it is. That should be a t. It is differentiable on an open interval a, b, or from a to infinity or negative infinity to a, or from negative infinity to positive infinity if it is differentiable at every number in the interval. Okay, so a function f is differentiable at a if the derivative exists at a. All right, so let's just look at this. Let's look at this. Here's an example we can look at. Where's the function f of x equals the absolute value of x differentiable? So we want to know, where is it differentiable? All right, so we're going to have to look at a few things. We're going to need to look to see if when x is positive, when x is negative, and then when x is 0. So let's take a look at that. So if we have, let me change colors. So if x is positive, okay, x is a positive number. So let's see how would we find the derivative? Well, we would have f prime of x is equal to the limit as h goes to 0, absolute value x plus h minus the absolute value of x over h, right? That's when x is positive. And remember, h is really, 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 really small. H is going to 0. So this would be the limit as h goes to 0, and the absolute value of x plus h, which that's positive. So that's just x plus h minus, and then the absolute value of x is just x, right? Because x is positive, over h. And so you can see here, we're going to get the limit as h goes to 0 of, what is that, h over h. You see that? Which that's just the limit as h goes to 0 of 1, which is 1. All right. So absolute value of x is differentiable for any x greater than 0. Okay, the limit exists for all positive values. So we got x, we got the limit equals 1. The limit of this equals 1. Now, what if x is less than 0? What happens then? Well, we got f prime of x is equal to the limit as, not x, as h goes to 0 of absolute value of x plus h minus absolute value of x over h. All right, so what does this equal? Well, this is what? This is the limit as h goes to 0. And what's the absolute value of x plus h? Now keep in mind, x is negative. So that's going to equal negative x plus h minus, and then the absolute value of x is what? Negative x over h. All right, so some of you watching this might be wondering, well, how in the world did you get that? Well, you've gone through the chapter of limits, and you should have run across this by, you should have already run across this. Okay? So remember, the absolute value function, that is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. That's your absolute value function. Now, remember, if absolute value of x, if x is positive, what we're taking the absolute value of, if that's positive, then that equals x. If it's negative, it equals negative x. Does that make sense to you? Let me show you. What if we want to find the absolute value of 5? Okay, let's just do that. Absolute value of 5. So this in here is positive, right? So that's going to equal this. I just replace this x with a 5. Now, what if I want to take the absolute value of negative 5? Okay, well, you see the x in here? See that x is what's inside the absolute value. So that's negative. That's less than 0. So this negative sign here, I'm going to write that down. And then what am I plugging in for x? I'm plugging in negative 5. Negative and negative, that gives us the positive. Okay, that's how it works. So since this in here is negative, it's equal to the negative of that. And since this x in here is negative, the absolute value is equal to the negative of that x. All right. So now we got the limit as h goes to 0 of negative x minus h plus x over h, which that's going to be the limit as h goes to 0 of negative h over h, which that's going to be the limit as h goes to 0 of negative 1, which is negative 1. So it's differentiable for values less than 0. We got negative 1 as an answer. All right. Now, what if x equals 0? All right. So, what do we got? We've got f prime of 0, because x is 0. See, here I did f prime of x, but x is just any positive number. X is any negative number, so I left it at x. I'm not doing it at a particular value. I'm doing it over an interval. All right, so this time x is 0. So this is going to be what? The limit as h goes to 0 of what? Absolute value of 0 plus h minus the absolute value of 0 over h. All right. And so this is going to be the limit as h goes to 0, and that's just absolute value of h over h. Now, we're going to show this limit exists, right? Let's see. Well, how do we do that? Okay. Remember back when you were taking limits, we've got to show that the limit from the left and the limit from the right are equal. All right. So if I take the limit as h goes to 0 from the right of absolute value of h over h, that's going to be the limit as h goes to 0 from the right. And so we're coming into 0 from the right, so that means the h values are positive. So the absolute value of h is just h, and so that's h over h, and so that's the limit as h goes to 0 from the right of 1, which is 1. All right. Now we've got the limit as h goes to 0 from the left of absolute value of h over h. See, I'm right now, what I'm doing, I'm calculating this limit here. I got to see what it equals. And so this is the limit as h goes to 0 from the left. So the absolute value of h is what? Negative h, right? Remember that h is negative. So the absolute value is negative h. It goes back up to this up here, what I showed you right here. Okay. All right, and that's over h. So this is the limit as h goes to 0 from the left of negative 1, which is negative 1. So this limit, it does not exist. F prime of 0, see, f prime of 0 does not exist. So the absolute value function is differentiable everywhere except 0. So what would the function f prime of x be based on what we found here? All right, so the function, so f prime of x, let me just write it here because I ran out of room. F prime of x is equal to what? It's equal to 1, right? See, it's equal to 1 when x is positive. When x is, well, let me write if x is greater than 0, and it's equal to what? It's equal to negative 1 if x is less than 0. And that's your function. And f prime of 0 does not exist. And what's f prime? Well, that's the derivative of the absolute value function. All right. So I hope that made sense. So if f is differentiable at a, then f is continuous at a. Okay, there's a theorem there. If it's differentiable at a, then it's continuous at a. So how can a function fail to be differentiable? Well, here's some things. If it has a corner or a kink in it, that's like this first graph here. Say this, because look, I mean, try to draw a tangent line. You can't. You got this. This would be tangent. This would be tangent. All that good stuff. And then if you have a jump discontinuity like this, okay, it's not differentiable. And then if you have a vertical tangent line, okay, so that's some ways that a function may fail to be differentiable. All right, so now let's look at this. We've got higher derivatives. We've got first, second, third, fourth, and so on, fifth, sixth, seventh, eighth derivatives. So the way that we represent them is like f double prime, we put the 2 marks there, f triple prime, or the fourth derivative. Now, this represents the first derivative, and then the 2 marks for the second, 3 for the third, but you don't put 4 marks for the fourth. Once you get past the third derivative, like if it's the fourth, fifth, or whatever, you put it in parentheses, like all the way up to the nth derivative. Okay, the nth derivative. So that's just, and another way that you can write it, if you want to write it in another form, you can write, like for the second derivative, instead of double prime, say like if you have y prime, remember you can write that as dy dx. If you have y double prime, you can write that like this. Okay, that's another way. Or if it's the third derivative, that would just be, those would be 3's. Fourth derivatives, they would be 4's, and so on. All right. So let's look at this. All right, so let's find a second derivative. So if f of x equals x cubed minus x, find f double prime of x. All right, so, well, we know that f prime of x is equal to 3x squared minus 1. Okay, now how did we know that? How do we know that? That was the very first example we worked. Let me show you. So if you want to if you want to look at that, see, we took the first derivative here and got 3x squared minus 1. So let's just pretend like we did all this work. So we did all that work to find the first derivative. Now, all we do to find the second derivative is we take the derivative of the first derivative. All right. All right. So let's do f double prime. So that's going to be the limit as h goes to 0, and that's going to be 3 times x plus h squared minus 1 minus 3x squared minus 1, all that over h. So this is f of x plus h, and this is f of x. All right, just using the limit. And so we get the limit as h goes to 0, and that's going to be 3 times, and that's x squared plus 2xh plus h squared minus 1. Okay, so how did I get that? Well, remember, x plus h squared is x plus h times x plus h. Just fold it out. All right, minus 3x squared plus 1. Then I distributed that minus. And so now what I'm going to do is I'm going to go ahead and distribute the 3. So let's do that. So that's the limit as h goes to 0 of 3x squared plus 6xh plus 3h squared minus 1 minus 3x squared plus 1, all that over h. So I just distributed the 3 for that step. And then we can see that the 3x squareds cancel and the 1's cancel. And so I am left with the limit as h goes to 0 of 6xh plus 3h squared over h. And then I can factor out a h. So that's the limit as h goes to 0. That's h times 6x plus 3h over h. And look at there, the h's cancel. So the limit as h goes to 0 of 6x plus 3h. Now I can plug the 0 in for h. So that's 6x plus 3 times 0, which is 6x. And that is the second derivative. All right. So I'm hoping all this is making sense for you. All right. So then let's look at, so we don't have anything else, any more problems to work, but let's just talk about this a little bit. So you've probably worked some of these problems so far: the position function, velocity, acceleration. So if we have a position function, s of t, then the velocity is just the derivative of the position function. And then if we take the derivative of the velocity function, that gives us the acceleration. So what that means actually is that the acceleration is what? That's the second derivative of the position function. And then if we take the third derivative of the position function, which that would be the derivative of the acceleration function, that's called a jerk. That's a quick change in acceleration. That's called a jerk. And then you could take the fourth, fifth, sixth derivative, and so on. All right. So hopefully this made sense. Hopefully you understand it now. But I will say, okay, you're not going to take derivatives like this. I mean, you may have some problems where your teacher says, use the limit to take the derivatives. And if they do, that's fine, do it. But, I mean, as far as what you're going to be doing the rest of the time in your calculus course, the next section, if you're on this section right now in calculus, the next section, you're going to learn your rules and stuff. And let me tell you this, okay, I hope a lot of you are still watching. These are the rules that you're fixing to learn: power rule, then you're going to learn product rule, quotient rule, chain rule. I mean, that's the whole key to it, those things right there. You've got to learn those. If you can get those, if you can understand that, then you've got it. But you've got to really focus on all this stuff, because you're going to have trig functions, exponential functions, log functions thrown in there, inverse trig functions, all that good stuff. You're going to have some nasty looking ones too. Okay, there's going to be some nasty ones. But, you know, just remember those basic ones: power, product, quotient, and chain rule. Okay, you gotta remember those. And if you can work those, it's easy. That's the whole key to calculus: knowing how to take derivatives and knowing how to integrate. Okay, and if you can get that, then you've got it. All right. So I hope this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you later.